So let's see if we can go to the book. See how that's going to work today. You guys want to know the bad news? You guys want to hear the bad news? Bad news is nobody wants to hear it, but I got to give it to you. You guys have class Monday. I know it. I have a class Monday. I do. They tell me I have to have class Monday.
Oh, no.
So I'd let you know. Monday we have a class. I'll be here. Yes. Yeah, it's Labor Day, all right. Okay, so we're going to go to, we said what, 1.5? See if we can get it to come to that channel. It's still not there yet, and it's taking forever. But anyway, we're on a page. What page you said? 60 something?
For 1.5, it's page 48.
48. All right. All right. I hate this. This is not working the way I wanted to. You'd think I'd be able to go right to the page. Not so far in this system. Let's see if we can get there now.
Doctor, I'm here.
Who would that be?
Melissa.
All right. Let's see who I have here. Melissa. Yulissa, you mean? Alvarado.
Yes.
I thought you said Melissa. Yulissa. Goodness, I'm glad you're here. All right. All right. Can you guys cannot see the book, can you?
No.
Yeah. I mean, this is, all right. Unfortunately, I'm learning what is working and what's not. See, now you should be able to see it.
Yes, we can see it.
All right. Okay, so now we're going to talk about intersections and sets. Conjunctions, inequalities. I think that lines up what we're supposed to do. And compound inequalities. All right. You can see the sign in the little box. It looks an upside down U. That means intersection. Union means all together. Let me do my own quick example. And then I'm going to skip all of this stuff because there's no sense in doing it. It's so easy. I think if it's explained correctly. Elizabeth Romero, do you need me? Are you good? Are you just saying howdy? Do I have that person? Yes. I'm just checking my notes here. Oh, can you look at it later? So look, here's what we have. If I have a set like this, a 1, 2, 3, 4. I call this A. I have B, 4, 5, 6, 7. And if I write A intersection B, that gives us the answer of number 4 only. Because 4 is in both of them. If I write A union B, that's like a family reunion. The answer is like this. 1, 2, 3, 4, 4, 5, 6, 7. Everybody agree with that?
Yeah.
I'm glad you all disagree because I'm glad you're disagreeing because I wanted to be sure that you read the same thing I read. The book says the union of those would be this. 1, 2, 3, 4. You do not repeat a number. 5, 6, 7. Remember that. You don't repeat it. So now you have the intersection and union, and you can never repeat them on a union. It's like if Bob goes, who's at the dance? Bob Smith, John, Sarah, Susan. Who went up eat? If you pick the same names, you're good. But if you add another name in it or repeat a name twice, who went to the dance? Bob, Bob, Bob. Well, yeah, I heard that name 3 times now. You only need to do it once. So that's the idea behind it. Hopefully that made sense. Kind of a bad example, but better than the book, I think. Hopefully. Okay. So A intersection B is the stuff where they're both in there, and that was 4 for our example. And we're going to skip some of this stuff because there's no need to go through it because it's just complicated. I mean, they just can make it longer. They can't make it any harder. And the only way it can make it harder is if you let it be harder because it's the same stuff. Intersection and union. Time to clean something here. I tried to buy a new piece of farm equipment today, and it's a pretty expensive piece. And a guy in Arkansas told me he has a brand new piece that he'd sell to me $2,000 cheaper than I could get it here. Well, let me tell you how that worked. When I decided to sign the deal, I find out he didn't have it. He says, "Oh, you got to get the more expensive one." I said, "No, I'm not paying more for it." So I called the place here, which is the boss of that place. The bottom line is they sold me it for the same price I originally guaranteed. Now, I mean, you got to be really careful nowadays. But the people here are good people. They just, sometimes you get people that are just, I don't know. All right, well, you guys get the idea. For example, 1, we're moving to 2. This is a
It's
number
very
line.
blurry.
That shows,
Yeah, it's blurry.
I didn't get that. What did you say?
It's blurry. You can't see it now.
I know.
Now it's clear.
Let's hope the next page is. Let's see. This thing has a mind of its own. Thank you, Sherry, for helping me out. Let's take a look. Anyway, the bottom line is I still spend a ton of money, so I've got to teach at least another couple semesters. Well, the Walmart sign has been going on forever. I don't know what's going on. So number 2. Okay. Yeah, let me
Still blurry.
teach number 2.
Still blurry.
Okay. Okay. I want to teach number 2 separately. Let me put this one. Let's go to the. I mean, I was going to do this anyway, so let's just do it. So we have Elizabeth Romero. Are you okay?
Yes.
I keep getting your name popping up. Did you have a question?
No. Wait,
You want to know what it's like here?
Mister, we haven't had any assignments, right?
Oh, is that what you want to ask? Let me see. Let me write that down. You have 2 kinds of homework. One is you study all this stuff in advance and any questions that you may have. Number 2 is items that I assign by the prof. I haven't assigned any so far, but you still have this. When I assign this one, number 2, you'll know it.
Okay.
Okay?
Mhm.
All right, amen. Now, let's go to the problem. Now, the book's going to show you a way to do this problem that I don't ever want you to do. -1 is less than or equal 2x plus 5, which is less than 13. Now, the book's going to tell you you can do these both problems simultaneously, and you can. But most students get confused, or it gets confusing, or it's just problematic. So we're going to set this up as 2 equations. First equation should be obvious. It's going to be the first half. It's going to be -1 is less than or equal to 2x plus 5. The second one is 2x plus 5 is less than 13. And by the way, I didn't mean anything by the homework response. I just wanted to make sure everybody understands that. Is that, please don't call my dean and say, Dr. Wickman doesn't give us homework. Yes, he does. And he will give you stuff that you got to hand in, but not quite yet. Secondly, you should always read this stuff in advance, and you should always go over the parts you don't quite understand. So I really appreciate that question, because I get that at least twice a day. And I want to make sure people are clear. So look, we're working these separately. So again, the first part here, that's where we're going to point the arrow. We're going to try to get x by itself. So we're going to subtract 6 from both sides. So we have -6. Or subtract 5 from both sides. -6 is less than or equal to 2x. Which gives us the 2x by itself. Again, I'm trying to get x by itself. So if I have a plus 5 on this side, I want to get rid of it by subtracting 5. But whatever I do to the right, I got to do the left. So technically, you're subtracting 5. So it makes it go away. I'm going to subtract 5 on this side, which gives you this. Now to get x by itself, I divide by 2. So I have a -6. Well, I'll just change that. I'll divide it by 2. I'll just say that's trace. -3 is less than or equal to x. Again, if I divide this side by 2, boom, you get x by itself. Divide this side by 2, you get -3. Now the other one is the same way. We've got to get x by itself. So we're going to subtract 5 from both sides. Little tiny 5. You get 2x then is less than 8. X is less than 4. So we have 2 solutions. X is greater than or equal to, and I want to show you this graphically first and then in interval notation. On your graph, boom. This being 0, this being a -3, and this being 4. If x is less than 4, I use a parenthesis. If x is greater than or equal to -3, I use a bracket. So solution is here and here. Now, in inner notation, it works the same way. It looks just like the graph. Bracket, -3, comma, though, 4 in parentheses. And that's the solution for that problem. Now, I went into it in detail. Why? Because I want you to work them separately like this, separate equations. Because when we get to more complicated math, you'll say, I'm glad I learned it this way better. And I promise you, I wouldn't teach you this unless I thought it was in your best interest. So I want to make my life easier too, because I want you to be successful. All right, so I'm going to go back to the book. Hopefully, we can get it to be more pleasant. Can you see the book now?
Yes.
Yes.
So look at the bottom purple. -3 and 4. That's, and you guys cannot see my stylus move, can you?
No.
Mm-mm.
So
Nope.
anyway, you can see it. It's the bottom graph. That's the solution. Now, number 3 is another one. Same thing. Only this time, they set them up as separate equations. Why? Because they're trying to train you that that's the best way to do it. So look, you have 2x minus 5 is greater than or equal to -3. Add 5 to both sides. 2x is greater than or equal to 1. X is greater than or equal to 1. That's a bracket. They show it in the first graph. Boom, it goes to the right, the red. The next equation is 5x plus 2 is greater than or equal to 17. Again, the goal is they want to get x by itself. So they subtract 2 on the left, they subtract on the right, you get 5x is greater than or equal to 15. Now to get x by itself, we divide the left by 5, we divide the right by 5, x is greater than or equal to 3, which is shown here in the blue. Now the solution can only be where it overlaps. So the solution, the purple one, shows 3 going on into infinity. The solution in interval notation is located in the right, that little tiny thing that you need glasses to see almost, or binoculars. 3, comma, infinity. And always when you have infinity, it's a parenthesis, no matter what. Are we good?
Yes.
All right. See about next one. Disjoint sets. All they're showing you here is there's no union, and everybody knows that. If there's no union in it, they don't have any similarities. It's the empty set, which is in this little brown box, which is at 0 with a line through it means nothing. Or in set builder notation, it has that bracket, nothing in it, close bracket. So all they're showing you in example 4 is that there's no solution, and that's the answer. So that's number 4. Number 5, they're doing it as 1 again. We're going to skip number 5 because I've already done this one for you. They're just doing it again as a single. They're working on both at the same time, and you don't want to do that. Now, they'll show you the next one, I believe 6, maybe it's 7. Well, they don't do that again. I guess they're just trying to show you that, they're smart, but it's not what you need to see or hear. All right, 6, the union. Well, look, they repeated 3. But the union, you can see they did not in the solution set, which is right above that little arrow in the moon. They did not repeat it. So the solution is 2, 3, 4, 5, 7, no 6. Just exactly what I already shared with you. They should be good with that. 1 second. All right, so let's look at number 7. Again, they're back to solving them separately. We have 7 plus 2x is less than -1. We want to, again, get x by itself, and they show it x is less than -4. You can see it in the red. The blue answer is x is greater than 2. And mathematically, everybody can do this. So the point here is that there's no solution except for the fact that it has or. So when it has an or, it means that they're both a solution, as you can see in line 3. But there's no intersection. That doesn't mean there's no solution. I think I misstated that. But the solution is all of 2 to the right and all of -4 to the left. They just don't have an intersection, but they have a union. And or stands for union in the sense it can be in one area or the other. So that's why in the solution here, you see a negative infinity, -4 union, bracket 2, infinity, close parenthesis. I hope that makes sense. Again, example 8. You have an or, so it's going to be a union. I don't think they work it any further than that. It's just supposed to be the same. All right. Number 9. Number 9 says, again, we have or. Well, this is interesting because look at the red line. The red line says we have all x is less than 5. The blue line says we have all, including -2, is greater than -2, greater than or equal to -2. So the solution is every number possible. So you can see the solution is infinity all the way to the left and infinity all the way to the right. And they're just giving you that as a solution. So renting off the space, this is a formula. It says the equation can be used, that's the one above here, r equals 2s plus 70. Can be used to determine the monthly rent, R stands for rent, for an office with S square footage. So a floor shop has a monthly rental budget between $17.20 and $2,560. It's kind of a pretty big budget. So they want to know if they have 720 square feet, if that will fall within the range of 1720 and 2560. So you plug it in the formula. You put 720 plus 70, which is going to give you 790 times 2, which is 2 times 790. You can use your calculator. It's 1580. Is that between those two numbers? Well, is it between it?
No.
So does that mean it's good or bad, or do we throw the place out, or what?
That's not good.
What would you do business-wise? I would go celebrate and say, man, we got a beautiful spot for below our budget. We're under budget.
That's fine.
That's what I would do. So now they want to know what is the range of spaces. So what does S have to be between 790 and 1210? So to solve this, in order to get the solution, it says if rent is between 1720 and 2560, you can put the equation between the whole R thing between 1720 and 2560. So here's your equation now. 1720 is less than 2 times S plus 70, and then 2560. Now you know how to solve this, and it's not like they do. You're going to solve the left-hand side first. If you do that, you get 2S plus 140. You add that number to, you subtract it from the left-hand side. Let me, I don't like it. Let me just show you how I would do this. I'm going to write 1720 is less than 2 times open parentheses, S plus 70, close parentheses, less than 2560. So let's go to that. After this, I got to take a little phone call break if one of our students has a question here. It's important. But let's do this first. Okay, so here we have it. The equation is 1720. And that has to be, the equation says R must be less than that, which is 2 times S plus 70. And then that's less than 2560. All we did is we put our equation in between our parameters. That's all we did. Now we're going to write 2 separate equations. 1720 is less than 2 times S plus 70. And then the other equation is going to be 2 times S plus 70 is less than 2560. So we're going to multiply this up. This is 1720. It's less than 2S plus 140. I'm going to subtract 140 from both sides because I want to get S by itself. 1720 minus 140. Does anybody know what that is?
1,580.
I think that's right. It's less than 2S. Get S by itself. I divide both sides by 2.
Get 790.
Is it 90?
790.
Exactly. Who said that?
Gift.
Thank you. So in order to get it in between the budget, she can increase her space all the way up to 790 at that rate. Now, what's the maximum she can get space? Well, this again becomes 2S plus 140 is less than 2560. I'm going to subtract 140 from both sides. It's going to give me 2S is less than 2420. Divide both sides by 2. S is less than
1,000. Yep.
So here's the parameters. 790 and 1210. Excuse me.
Bless you.
Thank you. So you got a chance to see this problem worked in the proper manner. And you can look at they have, and they have the same thing, but not the best way to do it. All right, so let me take 1 second. Let me put you guys on a little quiet time here. Go to the next page, hopefully. That didn't work. All right, bye-bye. All right, can you guys hear me?
Yes.
Yes.
See, I don't like the way this looks. Let me do this a different way. That thing does that sometimes.
Dr. Whitman,
Yes.
I'm gonna have to leave a little early because my daughter, I have to pick her up at work. If that's okay with you?
Who is this?
Alicia Moreno.
Alicia, let me look here. My notes on you. Alicia Marina. Okay, Alicia, do you have my address?
Your email?
No, my physical address.
No.
Because you can mail me a couple gifts. No, you're free to go. I'm just kidding. Be safe. Thanks for letting me know. All right, just know that what we're covering, you have that. So don't miss it.
It'll be maybe like 10 minutes before class ends.
Oh, no, okay. Well, we might be finished by then. We'll see. Okay, absolute value of number 1 is 5x. So you're going to take the absolute value of each part of the puzzle. So the absolute value of x is, in fact, the only part that is the difficulty of this assignment. Now, I do not like these examples. I'm going to give you an example that is really the best one. And what they're leading up to, I think. Hopefully you'll be. This is really kind of a neat part. And if you don't have this, then, it's troublesome. Okay, so look. You have here number 7. Let's go with that first. The absolute number that goes to the solution is 4 or negative 4. So here's what I want to show you. So if I have any absolute value problem, they put 4, let's put 7, just for the heck of it. The solution is always going to be plus or minus. Why? Because you put 7 in there, you're going to get 7. Put a negative 7 in there, you're going to get 7. So if you put these two numbers in there, you're always going to get the right answer. Now, let's do another caveat of that. Let's say I have the absolute value of x plus 3 equals 10. I'm trying to get us the same solution. Well, in order to do this problem, you got to get the absolute value piece of this puzzle by itself. So then you say the absolute value of x equals 7. Why? You got to get x by itself, so you subtract 3 on this side, subtract 3 on this side, you get 7. Again, the answer is going to be 7 plus or minus. That's what I'm trying to share with you. So whatever they put on this side of the equation with the absolute value of x, you got to get the absolute value part all by itself before you can solve it. And that's what they should be telling you. The absolute value of 0, by the way, or x, there's 7, I use it here, plus or minus. Oh yeah, I got to do this one too. Look at number 9. There's nothing that will produce a negative number. On the test, they're going to have something like this. I got to show this to you. Because students on all the other classes don't do very well in this one. Let's see here. They're going to put something like this. 7 minus 3x all over 2 absolute value equals a negative 3. You're going to say, what the heck? Dr. Wilkinson, we got to get x by itself so we can, but the deal is this. You don't even need to do it. The answer is this. Because nothing can be negative. Nothing. They catch you. I'll have students that will work this problem out and they'll give me an answer and I'll say, what? You didn't have the class. You missed the class. And you must have missed the review. And you must have missed the study buddy help. Anyway, you get that. All right, so now they're going to do example 10, just what I shared with you. They're going to subtract 5 from both sides to get 2x equals 4 divided by 2. Now, once you have the absolute value part by itself, it says absolute value of x equals 2. We know it's always plus or minus. Negative 2 and 2. I mean, pretty good. Let's see what else they come up with. Now, in marking this problem, I want to show you how they do this. Can you have an absolute problem value? So it's going to look like this when we do it manually. And that is, we have the absolute value of x minus 3 equals 3. Now, we all know that the solution for an absolute value must be plus or minus. Let me write that over again. Give more space. X minus 2 I get it right. It's equal to 3. Or the absolute value of x minus 2 is equal to what, class? What else can it equal?
Negative 3.
Exactly. Who said that?
Lizeth.
Zeth, you are right. It can only equal plus or minus 3. Now, once you have these two equations set up, you can do away with the absolute value sign. X minus 2 is equal to 3. Add 2 to both sides. X is equal to 5. Now, it's not plus or minus 5 here because we did the plus or minus. This is going to be our plus 1. This is our minus 1. But one of the solutions is 5. Now, let's look at the other one. The signs there. Now, this can be negative because your solutions are always plus or minus. So don't get nervous. I thought you said, Dr. have a negative number. You can't, but you can have it after you did the plus or minus thing. We're going to add 2 to both sides, so x is equal to -1. These are 2 solutions. I hope that makes sense. What we did is we separated it out, said 1 equals 3 and 1 equals -3. It's just like this. Yeah, the absolute value of x equals 3. Or you could write it x equals 3 or x equals -3. We separated it out. Now, what you can't have, you cannot have it playing x equals -3 like that. Nothing will equal a negative number. But you're trying to find out what possibility x can be to equal a positive 3. We all know that's plus or minus 3. And that's tricky, and I think that's why it's really good to have a class sometimes, because on the test, I don't want them to get you. I'm going to see here. Let's take a look at their solutions. They got 3 or 5 and -1, just like we did. So the same thing you can do for number 12, so we won't need to do that. Look at number 13. This is exactly what I was telling you about. It's no solution. Cannot equal -8. An pure absolute value machine cannot equal -8. Now, let me give you one more. Shoot. I want to do this one just because some people panic and think it can't be done. But it can. It's kind of like the rules for exponential notation. If you follow the rules, you can't go wrong. So I'm going to give you the problem, and you should be able to see why. Some of you will. Most of you will. Maybe all of you. We get rid of this Walmart thing here. Okay. Let's take a break on this one. We'll go to what I wanted to show you. And here we are. So, if I say I have the absolute value of x minus let me see, minus what, 7 is equal to a -2. You're going to say, oh, it equals a negative number, can't be done. Well, but remember, you can only solve this after you move and get the absolute value by itself. So this is really technically absolute value of x is equal to 5. Now the solution is plus or minus 5. Notice, yeah, you have a negative here, but this number here had not been pushed over there. Now, on the contrary, let's do it like this. If I add 2 to both sides, I got absolute value of x is equal to -5. Is there a solution? No.
No.
Yeah, exactly. You can't get a solution. So just trying to show you some of the tricks. Good deal.
Can you do another one?
Nah, you guys got it. What? Let's see here. Of course I can. I'm just kidding you. All right, so here we have, let's say, you just want me to pick any kind?
I'm just a little confused on how this one, like the absolute value of x minus 7 equals -2, can still have a solution, but the other one couldn't. So
Okay, so look, you have the absolute value of x minus 7 equals 2, or -2. To get absolute value by itself, what do I got to do to the left side?
you gotta add 7.
Yeah, add 7. If I add 7 to the left, I have to add it to the right. So the absolute value of x is equal to then 5. So it becomes positive.
So the reason that it's able to be solvable is because it becomes a positive number.
Yeah, it can always, an absolute value can only equal a positive number. Now, on the contrary, I wrote absolute value of x minus 2 equals let's say -7. If you add 2 to this side to get it by itself, you still have the absolute value of x. But what do you have on the other side?
That makes -5. Okay, I get it now. Thank you.
All right. No problemino. I kind of was teasing you a little bit. So look, now the next ones that we need to do. Let me do 15. Absolute value of x plus 8 equals absolute value of x minus 5. I'm going to do this one because, again, they make it look hard, but it's not. So I'm going to give you the problem. It says absolute value x plus 8, absolute value, equals absolute value of x minus 5. Now, in order to do this problem, you're going to break it down to plus or minus on this side. The side's going to be plus or minus. So we can say x plus 8 equals x minus 5 for a solution. Or we can say x plus 8 equals a negative parentheses x minus 5. Remember, it has to be parentheses because it's all in a bracket. So we're going to get x by itself. You get 8 equals -5. You can't do that, so there's no solution there. Let's do this side. This becomes x plus 8 equals a negative x plus 5. I want to get x by itself, so add x to both sides. I get 2x plus 8 equals 5. Again, I want to get x by itself, and I want to be positive. We'll subtract 8 from both sides. I get 2x equals a -3. And then divide both sides by 2. X equals a -3/2. Bueno. No bueno. Questions about this one? Again, you set the right-hand side up as if it's plus or minus. You have to use a parenthesis for the minus because it changes everything inside. When you get x equals -5, there's no such number that works. So there is no positive solution for that. There's no x that will work. None will equal that. But if you put in x equals -3/2, you'll find that it works. Okay, let's go back. Let's see what the book says so you can get an amen to that and see if they did the same thing that I did. And yes, the only solution is -3/2. Again, back to 16. The solution is 4, -4. They show it in an ordered pair system. Now, if we do a less than, we simply have to do it like number 17 shows. Remember, x can never be greater than 4. So look at the interval notation solution here. If x is 4 equals it, so use a parenthesis on the right-hand side. But remember, it's always plus or minus. So you put -4 on the other side. It can't go beyond it because a -4 in, you guys know this, that if I put inside the parenthesis a -5 inside the absolute value, it's going to equal 5. So that's no good. So the solution only can be at -4 because that comes out as 4 again. So solution is -4 all the way back and forth to a +4, but it's less than it, so you always have to have those things. So in interval notation, this is -4 and 4 like that. Actually, they use parentheses. And for graph, you'd have the graph, boom. And I'm just wasting your time by drawing it again, but you could see it. It has to be in between here. And you can, and if you don't trust your answer, test it. Try 5. Is 5 going to come out to be less than 4? -5? No, not. That's the most they can give you in terms of problems for absolute value. That was at 17, 18. Oh, greater than equal. The only thing different about that is use a bracket. Is there a 19 and a 20? Maybe. Let's look down further. It's talking about the solutions using the graph to see it. Using infinity, parentheses. Surely they'll give us one more good word problem. Well, 3x minus 2 is less than 4. We have the absolute value. So they write, look, let me do this again for you on the other paper. They're doing this one simultaneously again, and I don't like that because it's too confusing for most students. So I'll show it to you again. Let's do it. And some of you might feel better. I'm hoping you like it. Hopefully like me trying to make sure you know. So the first one we're going to write is the absolute value of 3x minus 2. Absolute value is less than 4. And since we know it's plus or minus, the absolute value of 3x minus 2 is less than -4. Now, I want to put a star here because this is really critically important. When you change this to a -4, this goes this way, changes. So this now becomes 3x minus 2 is greater than, was it greater than or equal or just greater than? Just greater than -4. So when you make this a negative number here, the sign changes. Let's solve this one first. 3x minus 2 is less than 4. 3x is less than 6. So add 2 to both sides. X is less than 2. So drawing the graph, this is 0, this is 2, it's less than it, so it's a parenthesis, and it's starting to go that way. This one, we have now 3x is greater than a -2, because I have to add 2 to both sides. Divide by 3, x is greater than -2/3. So here's a -2/3. That's greater than that, so your solution between here and here. In integral notation, it looks like this, -3/2, parenthesis, comma 2. The only key, and this is critical to note, is that this thing changes on an absolute value when it's on both sides, when you make it a -4 and you have a greater than or less than sign. If it's an equal sign, it can't change because equal is equal. But if it's a greater than sign, it becomes less than. If it's a less than, it becomes greater. It just switches. Just remember that. And I think that's it for today. I think. Let's take a look. I know it's a lot on that last one. I know we spent some time on it. And you wait. I didn't show you the solution. I should have. Did I go too fast? There's your -2/3, and there's your 2. They're all the other same. They're just changing signs here. 21's a good practice one if you want to do the same thing. Except for if it's greater than equal, you know it's a bracket. Remember, yeah. So again, I want to emphasize this one point. If you have X is greater than or equal, it's always going to be a bracket. Might be a bracket this way or the other. But if you have just X is greater than, or if X is less than, these are always going to be parentheses. All right. Did we cover everything for today, or do we got another chapter? We didn't do 2.1 yet, did we?
No, we haven't.
Nah, we need to do that. So, let's see, what's the prayer? Yeah, we don't have much time. Yeah, we got to go to there though. Sorry, okay, got to do that. The page.
That's page 74.
Perfect. Who is that? Is that my page person?
Yes.
Don't tell me. While it's getting there, that would be Lizette.
Yes, it is.
All right. Appreciate that. Thank you. Now this won't be too much. I won't take too much of your time. Graphs and equations. Plotting ordered pairs. I hope you all know that a graph is divided into 4 quadrants. Some students have trouble with them, but notice everything on the right for X is positive. Everything on the left of X, which is the horizontal line, is negative. And here you can see it right here. So just practice these points. A negative 4, 3 means the X is negative, so you go to the left. That's probably down here. Yeah, negative 4 here, and up 3 because it's positive in the Y. Next one is negative 5, negative 3. Well, the X is negative on the left, and the Y is negative down. 0, 4 doesn't go anywhere on the X, but on the Y it goes 4. Remember, the ordered pairs are X and Y's. 2.5 you got to do interpolation. That's between 2 and 3. You can see it right here. You need to practice that. The quadrants, you don't need to know the name of the quadrants. This is 1, 2, 3, 4. They work counterclockwise. 1, 2, 3, 4. On the right, it's positive, positive. I used to think when I was in class, geez, I got to memorize it. It's positive, 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 negative. But everything on the right for X is positive. Everything on the left for X is negative. Everything on the top for Y is positive. Everything on the bottom for Y is negative. You're going to say, okay, it's easy for you, but use your brain. There's a pattern here. And come up with it so you don't forget it. I don't care if you know what quadrant's what. But you need to know what goes in them. All right, determine whether each of the following pairs is a solution of this. Well, you just plug it in. Now, notice that, and they don't tell you this, but the numbers in the order of A and B. So, A, in fact, is 2. B is, in fact, 8. So, 8 times 5 is 40, minus 6. So, the answer is 34, and it is correct. Remember, the ordered pairs or pair is 2, 8 in this case. 8 is the B, and it goes in there. So it's 40. You get 30, 34 for instance, minus 6. So just remember the order. Don't mess that up. There's a little key here. It says, in parentheses, alphabetic order of the variables. They know that little thing. They usually should say A comes first, B comes second. Here's some more. They just try them out. You plug them in. You pick the number. Negative 4, half of negative 4 is 2. Everybody knows that. A negative times a negative is positive. So 1 plus 2 is 3, and it equals. So 4 is true, or 3 is true. Again, you just got to practice plugging them in, knowing which one's the X and which one's not. If you put 3 in for X, you're going to be in trouble. If you put negative 4 in for Y because it comes first, you'd be wrong, because its ordered pairs X, Y. Now, on a graph, on a line, by the way, they will all end up on the same line if the ordered pairs are correct. I'll give you a quick example. I'll give you my example. It'll be better for you. If I say x plus y equals 10, this is a line. Why? Because there's no squares, no roots. You have just a plain x and a y. So if I say in my t-chart, x and y, if I say x is 1, y must be 9 for an order pair of 1, 9. If I say x is 5, then y must be 5. That's a y. So that gives an order pair 5, 5. If I say my x is 3, my y becomes 7. Now, if I'm going to graph this is my x, and this is my y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The order pair 1, 9. 1, 9 is here. This is your x, and this is your y. Next order pair is 5, 5. So 5, 5, right here. And then 3, 7. 1, 2, 3, 7. Straight line. They had to be on the line because this is a line. And if all three of these solutions work, they all must be on that line. And that's what they're trying to tell you. Otherwise, they're not on that line. So they start out with an easy one, y equals 2x. Now notice at the point 0, 0, it's also called the origin. But look, if we put in 1 for x, y becomes 2. 1, 2. It's on the line. Has to be, because it works for the ordered pair system and the equation. Next. Then we'll get there. Graph y equals a half x plus 3. Well, I always use 0 for fractions because then the y is equal to 3. But you create a t-chart. You make the numbers whatever you want so that life is good for you. You don't want any fractions, so make the numbers so you don't get fractions. So if you have a half of something, make it an even number. That way if you take 6, half of 6 will be 3. And then 3 plus 3 gives you 6 again. Use the negative 6, because a negative over negative is a positive. I mean, you can build this chart any way you want yourself. But the bottom line is, if whatever you put in for x, it has to equal y. And that's your ordered pair. And you should practice these. You have all weekend to do this. Thursday, Friday. Is there a question? Somebody bailed on me? When I have the text, by the way, I can't see what you guys are doing. If that helps. Okay. So, 6, no different than any other number. But now look at your graph. You pick numbers. Where do these numbers come from? Your brain. Here's your equation, 3x plus 5y. I don't like the 3x, so I'm going to make that a 0. My x is 0. If x is 0, 0 times 3 is 0, so my y must be 2. So you have 0, 2. Boom. You put that in there, you draw that, put that dot there. Then they pick 2 other numbers. And then you can draw them a line. On a t-chart, which you build, The rule says that you want to try 2 for sure, but 3 is recommended. Why? To make sure you didn't screw up in one of the other numbers or dots or make a mistake. Now, I've got to show you something else.
I'm leaving now, Dr. Whitman.
You what?
I'm gonna leave, pick up my
Okay.
daughter.
Okay, hasta vista. I'm going to show you guys something really important with your calculators now. I'm going to do this for you. Let's see what the next page says. See if I can make it tie into the class a little bit differently. But what I'm going to show you is going to save you thousands of moments of headaches, hopefully. Let's see. Okay, well, by the way, they're just simply showing you here that these are not linear equations. They're just not. And yes, this is perfect. So these are non-linear because they're not a straight line. Now look, you have here is y equals x squared minus 5, and they want you to build a t-chart for it. Now, you all paid good money for your calculators. So let me show you something about your calculator. See if I can pull that up pretty quickly. There it is, boom. So I'll wait for a second for you to get your calculator. Hope you have one. Okay. I'm thinking you have it. All right. So if your equation is in the form of y equals x squared, that means y is by itself. Look up at the top of this calculator. I'm pointing to it y equals. That's what this says, y equals. And we can graph it then. And this thing will do everything. It'll graph it for us. It'll show us the t-chart. I mean, it's just wonderful. So I'm going to put it in. Y equals x squared. So here's our x's right here. There's our x. We want it squared. We're going to upper arrow it here. We're going to square it. And then it's at minus 5. In this calculator, I got to push out of this and then put 5 minus 5, not negative 5. So this equation is exactly like the book. Now, sometimes they're not going to be in the form of y equals. You got to make it that way. For example, if they had 2 on this side, you just push the 2 to the other side. But now we're going to graph it. Now, you do not hit enter. You're going to hit up here, it's the graph. Boom. And it's going to graph it for you. Now, some people will have a calculator and say, Doctor, I don't get that. I did everything you said. Well, look at your window. I'm going to click window right here. When we work our calculators, I set our windows at minus 10, 10, 1. Y, minus 10, 10, 1. It's all under window here. Now, it's on tape. You should catch that. But that will make it look like what we're doing here. Hopefully, you'll pick up on that. So we'll go back to y equals. That's our graph equation. And then we'll go to graph. That was our equation for the graph. And now we're going to go to the graph. Now, Dr. Wickman, let's say, okay, I got this. It looks pretty. But you want a t-chart. So you go to second, boom, and second means all the blue things take precedent. So instead of graph, we want table. It's right above graph. There's the table. Negative 5, 4, 3, 2, 1, 0, 1, 2, 5. Now, if you want more numbers than negative 5, you just push it up. Use the arrow. Keep going all the way up you want. I wanted to go down, I down arrow. So this, you need to practice this because on the test, you'll get frustrated with some of the problems and you can just put it in your calculator and life is good. Now, I didn't mean to take all your time on that, but this stuff is important, and I'm here to teach you, and that's part of the deal, I guess. That's not. What happened to our text? Well, they say, whoa. Well, it disappeared. For some reason. I don't know why. We're on 2.1, right?
Yes.
And what page were we just on there? Do you know?
I think it was 79.
And I put you in the spot.
It's page 80.
Oh,
I'll put you in the spot. That's all right. So let's go to 81 then. If that was 80, we'll see if we get there. I don't know how come that disappeared. Here we go. Again, we will not have class for about a minute or two longer because I tried to get you out here at 8:20. That was my agreement. But let's see once if we got anything else that's critical. Absolute value graph y equals x. Just note that whatever x is, y is, except for it's negative. But it's going to come out positive. So if you say your x is 1, you put 1 inside this, it's going to come out 1. If you put your x is negative 1, it's going to come out as a positive, and that's why you get this v. This is a standard graph, number 9. You should just memorize that. Or note that happens. Next page. And most people, okay, that's it. So you had 2 other things here. That's it for tonight. I appreciate you guys' patience. You're good. Let me just go over the roll one more time to see if anybody that came in late that I got. Did Mary Ellie make it?
Yes, I'm here.
You did? Good deal.
Yes.
Mary Ellie, good for you. How about Azia? No, Green didn't make it. So it's everybody first. That's 100% participation there. How about Briannia?
Yes, I'm here.
You're here
I'm
too?
here. Yes.
Wow. Golly. How about Geraldo Ramos? My last one. If you're here, it's a home run. Okay, that's the only one that's missed. Okay, guys. Anything of me? Remember class Monday. Be safe. Send me money. No, I'm just kidding. I know it's taped. She's right. Just kidding. I'm just kind of happy with you guys. You guys are a really good class. I appreciate y'all. Anything for me that you have any questions?
No, thank you.
No, thank you.
So did we finish? Oh, I'm sorry.
Go ahead.
Did we finish off on 2.1? We finished and we're going to start on 2.2 on Monday?
We finished 2.1. Yes, we
Okay.
start 2.2.
Okay, just making sure. Thank you.
That's right.
You have a good night, Dr. Whitney.
Man, I appreciate you. Thank you.
Thank you. Bye.
Thank you.